This is Josh Wood with my Red Hat colleague and co-author, Jason Dobies. Now, Dobies and I can fairly claim to have written a book on Kubernetes operators. And we're here today to give you the short, sweet, true gin on operators, what they are, how they work, what you can do with them, and how to build them. That's the course of these three videos. At the end of each episode, we'll tell you where you can get a free copy of the book to learn more. So let's jump right in. Really, what you want to know is, why should I care about Kubernetes operators? What can they do for me? Well, at a high level, the answer to that is really that any application on any platform, whether it's your mobile phone, your web browser, your operating system and its package manager, you've gotten used to the concept that applications that run there have to be installed, configured, managed, and upgraded over time. As a corollary to that, keeping software up to date is your best defense in the continuing arms race with security vulnerabilities and other compromises that can affect your software and the data stored there. So automation is key to what the operator's idea is all about. Kubernetes itself is about automation. And in fact, that's what brought a lot of us to Kubernetes. If you're running a simple stateful application like a web server, it's very easy for Kubernetes to replace or repair a deployment of that server, because one instance is as good as another. There's not really any state or anything to know about a particular user's session that has to be maintained when one of our web servers falls over and we start a new copy in its place, or scale that service up and down across more than one pod on a Kubernetes cluster. With operators, we can extend that model of automation and teach it about the internal application-specific state that makes our applications and our operations automations run and work in the real world. So if you're real familiar with Kubernetes, operators can be explained in a way that's very short, but not necessarily very simple. And that goes something like this. A Kubernetes operator is just a combination of an application-specific custom controller watching an application-specific custom resource that represents, in Kubernetes API terms, the internal state of that application that the custom controller wants to manage and reconcile in the usual reconciliation loop that we always find at the heart of the Kubernetes control plane. But what about more complex applications that might have state or their own notions of clustering? Well, likewise, to deploy a database on Kubernetes is pretty easy. You find an image in some container registry, you deploy it as a pod on your cluster. But actually running that database in a production sense over time is much harder. It may have its own notions of clustering, its own notions of who write leaders and read followers are in a cluster of multiple instances providing that database service. When your database needs to be resized or upgraded, unlike our web server example, we can't just add a new one. We have to configure that new member to join with the existing cluster members, to find those database endpoints, and to find read and write follower relationships. Perhaps it needs authentication assets to become a member of an existing group of servers running as a database cluster. When we want to back that up, we have to maintain the service in the face of that backup and apply something like a rolling strategy to take individual cluster nodes offline so that we can snapshot their data and back it up in a consistent state. Healing from application failures, likewise, more complicated for complex stateful applications, because we can't just add a new copy. There is important state and configuration that every member of a database cluster or a file system cluster is going to need to join the cluster and perform its job. Now, usually there's a human, an operator, an operations team, an SRE, a site reliability engineer, or a DBA running a database, or a group of database servers running as a cluster. If only Kubernetes knew about the internals of those complex stateful applications so that we could apply Kubernetes style automation in Kubernetes API terms to those complex stateful apps. Operators represent a way to teach Kubernetes about the specifics of an individual application, its so-called operand, that operator manages and keeps running and maintained and upgraded over time. So we're back again to, how does that happen? As we mentioned at the outset, by extending the Kubernetes API, by providing a custom resource that describes that application's internal state and a custom controller that watches that resource in a loop and knows how to take application-specific actions to correct the actual state of that application on the cluster to the desired state represented in that custom resource. So you can think about operators as automated software managers, or really, as I like to put it, as software SREs that know how to manage the whole life cycle of complex, clustered, stateful applications on a Kubernetes cluster. So this is sort of what a custom resource looks like. And I'm going to turn it over to Jason Dobies to give a description of how we're extending the API here and teaching new words to Kubernetes concept of the world.
All right, so like Josh said, it's built, the operators are built on top of existing Kubernetes primitives. It's really more of a paradigm for how to use Kubernetes and how to use OpenShift, since you've probably heard in other similar talks, OpenShift is Kubernetes. So a custom resource definition, and this is not one of those, this is a resource, but the definition teaches Kubernetes that, hey, I can now have a resource of this particular type. So your vanilla Kubernetes, your vanilla OpenShift, you can create pods and deployments and config maps, and those are all built-in resources. But a custom resource definition lets me tell Kubernetes, I want you to also be able to create databases, and I want you to be able to create message queues, and I want you to be able to create my particular blog or my particular application. So this is an example, once the CRD or the custom resource definition is defined in the system, this is an example of what the end user is going to use to interact with your operator. And really, I said it that way, but that's effectively interacting with my application. So my awesome database here, you can see we have a cluster size of 3, read replicas of 2. That's going to create a number of resources. We're talking about a number of deployments and replica sets, very likely secrets and config maps to handle all of the authentication, potentially other things going on to handle any kind of sharding or replication. So there's a lot of pieces that go into deploying a production-ready database. It wasn't an accident that we chose that as the kind here. For the end user, they just know, I want to deploy my database, and here's how I want to configure conceptually the idea of my database. The custom resource definition allows the user to speak in terms specifically of my application. The other piece he talked about, and I know there's a lot going on in this picture, so bear with me and I'm going to take you through it. This is going to be a little more relevant to when we talk about writing operators in the next session, but it's helpful to understand, especially if you've never really looked under the covers of Kubernetes. And if you haven't thought a lot about how the declarative API works, this may clear some things up. So starting at the left, we have our little user who modifies or creates or in some capacity changes a resource. And what they're actually doing when they set a configuration on a resource. And again, this is any resource, deployments and pods, but also my production database and my WordPress blog. I'm telling Kubernetes, I want my resource to look like this. Now, I'm not giving it fine-grained operations of saying, create this piece, delete this piece. I'm simply saying, this is the end state my resource should be in. Now, the controller, that other built-in Kubernetes concept that Josh talked about, an operator implements this controller to understand how to take that request for the desired state of a resource and actually make it so. So that can mean any number of things. That can mean deploying a couple of local Kubernetes resources. That can mean connecting to and deploying some kind of external resource to the cluster, some kind of legacy system. That may even simply mean reaching inside of one of the running pieces and changing them. For instance, if I were to have a resource that represents a database backup, it's not going to create any new deployments and pods, but it's going to do something that affects the resource itself. This is all done in something called a reconcile loop. We're going to spend a little more time on that in the coming talks, but for now realize that the controller is constantly sitting there in Kubernetes and waiting until a change to one of the resources it cares about gets sent into the system. Then Kubernetes says, hey, you're paying attention to this particular resource. Here is an update to it. Make sure that whatever's being requested of it is actually reflected in the real world. Next slide. So it was an extremely fast crash course on some of the details. Obviously not too deep. I didn't want to go too heavy in such a short talk, but it really starts to introduce the important concepts in an operator and what makes it up. Is that we have this controller piece that lets us actually reconcile our state and do the business logic. Now note, I haven't said anything about programming languages yet. That's coming in the next talk when we start to talk about the SDK and how we go ahead and write one of these operators, as well as some of the external, the other frameworks that exist outside of the SDK that facilitate different languages. But the other piece was, again, that custom resource definition. And this is what your users are going to interact with. This is your API. Now, very quickly, we have a couple of links that have been up here. So hopefully you've been frantically scribbling them down or at least screenshotting. I will point you to the third one on there, this learn.openshift.com. These are self-driven scenarios that you can access for free. They're about 10 to 15 minutes each, and they will take you through everything from some basic Kubernetes concepts like the custom resource definition and controllers we talked about, all the way up to building and deploying your own operator. So by all means, check those out. It's a really good way of getting your hands dirty without having to set up your own cluster and setting up some kind of build environment. And then the last link there, as Josh mentioned earlier in the talk, the copy of this book is available as a PDF for download, so you can use that link to find it. Josh, if you want to go to that last slide. In hindsight, you know what? Forget it. Go back one slide. This slide's not that interesting. This is the interesting slide. So I'm going to end on the links here. In the next session, we're going to talk about the Operator SDK. It's a CNCF project that facilitates writing and testing operators. And then from there, we're going to talk about, in the following session, about other types of frameworks and different things you can do with operators. So with that, we're running a little long on time. On behalf of Josh, I'm going to thank you for paying attention, and we will see you guys next time.